Hello everyone, welcome to this online Python tutorial series. I am your instructor Kushal and let's get started. So the first thing that we are going to do is download the required tools and softwares, and for that we are going to open a browser window and then search for Python, and usually the first link that comes up is the Python official Python website, and in the menu you can see an option for downloads right here. So click on it and the download must start. And another software that we are going to need is VS Code. It is a text editor, meaning that it is the software that we will use to write Python code. So we shall also download this, and after the download is complete, I need you guys to install both of these softwares. As I've already installed them in my machine, I would not bother doing that. Yeah, so I forgot to mention one thing, that after installing VS Code in your machine, what I need you guys to do is to install the Python extension inside the Visual Studio Code by going to menu and then clicking on extension, and then you can search the Python extension in the marketplace. I have already installed it, but you will get an option to install it, and please install before continuing with the series. Now after the installation is complete, I want you guys to create a new folder for the tutorial, and I'm just gonna name it Python tutorial. And upon right clicking on this folder and clicking on show more options in Windows 11, you must see an option open with code. So if you have this option, click on it and it will create a Visual Studio Code workspace. And if that option is not shown to you, don't worry about it. You can go to your search bar and search for Visual Studio Code, and it will and then it will open a new workspace, and then to go to the workspace of the folder that you just created, you have to go to file, open folder, and go to the directory and select Python tutorial, and we can close this get started tab, and let's create a new file by clicking here, and let's name this file first.py. So the .py is the extension of the file, and it says that this is a Python file. So the system will now understand that this is a Python file and work on it. So yeah, now we have created a file. Let's save it and let's take out the folder, and as you can see, here is first.py with this kind of logo here, which is the Python logo, so the system does recognize it as a Python file. Now let's move on to Visual Studio Code. I'm going to close this tab by pressing Ctrl plus B, and let's talk about variables. I think the font is a bit too small, so I'm going to increase the font size um, a little bit more, and this must be enough. So before talking about variables, I would like to talk about this line. This line here is colored green, and it starts with a hashtag. So a hashtag in Python denotes that it is a comment, and a comment is such a sentence that is not executed by the Python interpreter. So I can write whatever I want here and it will simply be ignored, and it does not affect the program at all. So talking about variables, it is just like variables in mathematics and any other things. So I'm going to create a variable called my age, and I'm going to insert a value of 29 here. So what's happening here is the value 29 is being stored on our RAM or our memory, and it is it is being stored by on a placeholder called my age. So my age is what we will use to refer to the memory location of 29. Maybe I'm complicating things a little bit, but yeah, to simply put it, you do not need to understand much of it right now. It's just that variables are names that in which we can store values, and that can change. We can change the value stored in the name or the variable. So I can say, let's say 2 years have spent by, and now I can change my age to 31, and it will not give us an error because it is a variable and we can change the value. Now let's move on to data types in Python. So talking about data types, we are going to be primarily talking about primitive data types for now, and the first data type that we will talk about is integer. So the current example that I showed was my age is equals to 31. So the value 31 here is an integer, so it is an integer data type, just like in mathematics. And we can also, integers range from positive numbers to negative numbers. So it can also be my number is equals to negative 567. This is also an integer. I guess that was pretty simple. Now let's move on to another data type, so which is strings. But before that, I want to talk about strings in a different approach. So let's say we want to store a name in a variable. Let's say we create a variable called name, and my name is Kushal. So I'm trying to store this name inside this variable. So let me rename this variable because it might get us confused. So I'm going to change this to my name. And as you can see, this Kushal has been underlined by something, a curly line, and upon hovering on it we can see that Kushal is not defined by lines and it shows some kind of error, right? This is because Kushal is a series of alphabets, or we can call it a word, right? So it is a combination of letters of the English language, and to create a word or sentence or a single alphabet in Python, we need to put it inside either double inverted commas or let's create a new variable, my friend's name, and I can put it in single inverted commas as Alex. So to write a name or anything of the English alphabet, we will put it inside the single inverted commas or double inverted commas, and this is exactly what we call string. So this data type is called string. And now talking further about string, it does not have to be necessarily a single word. It can also be Kushal is a nice guy, right? So this is also a string. And a fun fact and a fun thing is that even strings can be numbers, right? So let's say another string. I'm not good at naming variables, but let's say Kuso has lived 89 years. So we can also put numbers inside strings, and that will work, all right? Because even in the English language, we use numbers not just for mathematical purposes, but also for these common language purposes like what we have used here. So another data type that I want to talk about is float. So as you can see, we have discussed about integers, right? But integers in mathematics also contain numbers that have decimal points, like let's say 78.32. And such type of numbers are classified as a data type float. So let's say my marks in exam is 78.32, so this data type is a float data type. Now the last data type that we will talk about right now is Boolean. So Boolean is really straightforward. It is true or false. Sorry, it is true or false. So true basically means that it is one, and false basically means that it is zero. In machine language, 1 means switch on, and 0 means switch off. So this is what exactly true and false means. So, and to use booleans, we can make is Kushal a guy? And yes, I am a guy, so it's going to be true. But does Kushal live in USA? No, I do not live in USA, so it's going to be false. So these are the data types that we have discussed till now, and there will be more data types that we will keep discussing about later on, but these are the basic ones. Now we have done a lot of things here. We have declared various variables, but when we run the code, it gives us nothing. It is because we have only declared variables. We have not interfered with input and output. So let's first talk about output. So let's talk about input and output, IO. So print is a command that helps us to print whatever is contained within these small brackets to our screen. So the classic example is always hello world, and after running this program, we can see that hello world is outputted to the screen. So let's look at this command once again. So print is followed by a small bracket, and inside the bracket we can give whatever values that we want, and it will be printed to the screen. But right here we are giving the value directly to the print command. But what we can also do is we can give the name of the variables, and the value inside the variables will be printed out. So let's give the variable my name inside the print command, and let's run it, and here you can see that it prints out Kushal. So this is about the print statement. Now to take input from the user, we will use a command name input, and inside the brackets we can give prompt to the user. So we can give a prompt like please enter your age, enter your age. Now this entire command will take an input from the keyboard, but we need to store it to an integer. So let's create an sorry it we need to store it to a variable. So let's create a variable your age is goes to input enter, please enter your name. So as I run this, here you can see it gives us a prompt, please enter your name, and I will enter my age. Oh sorry, it should have been please enter your age. And as I run this and I give age 85, nothing happens. It is because we are just taking an input and it is being stored inside your age, right, in the variable your age. We are not doing anything with it. But what we can do now is we can print your age, and let's try this. Okay, I'm entering my age 45, and it gives us 45. So yeah, we have now learned how we can input and output. Now let me clear the screen, and we will now talk about another type of data types, which are lists. So list is a data type in which we can contain multiple values, just like what we have lists in our real life. So we make grocery lists, right? And we write the name of different groceries that we want, like let's say oranges, yeah. And we will get a flour, and we will get let's say detergent, and the last thing that we will get is okay, Coca-Cola. Okay, Coca-Cola. So this is how we usually make a list, right, in real life too. Now in Python, what we do is we enclose the values, the list inside big brackets, and then we will just store it inside a variable. So grocery list is equals to oranges, flour, detergent, Coca-Cola. And lists are also not available in every other language. It is like a special feature of Python. In most languages, there is a thing called array. And the thing that distinguishes a list from array is that array is defined. You can, if I declare an array as an array that contains 1, 2, 3, 4 values, then I cannot change the size of the array to contain 5 elements. But a list is dynamic, so I can just I can append another thing, I can add another thing to the list. So to do that, what we will do is grocery list dot append, and inside the bracket we will give the value that we want. So what do we want? We also want to bring apples. So to see whether this has worked, we will first make a print statement over here, print grocery list, and after adding the value apples, we will again print grocery list. And as you can see here, firstly there were 4 elements inside the list, and after adding there are 5 elements inside the list. So this is a very special feature of list, and it makes us to work, it makes working with list very easier than what we have with arrays, because we need to know before creating an array how many values we will contain inside the array. But for list, we do not need to know how many values we will contain in the later period of time. So another data type that is really similar to list are tuple. So tuple are just like list. So let's say my coordinates, yeah, and coordinates are generally in x and y, right? So a tuple similar is really similar to a list, but instead of using a big bracket we will use a small bracket. And let's say my coordinates are really random, 23.45 and 45.98. So the difference between tuple and a list is that a list can be appended, it can be modified, but a tuple is constant, so it cannot be changed. So once a tuple is declared, we cannot interfere with it. Let's try adding a value to my coordinates. Let's add a z coordinate, which is not really practical. We use two-dimensional coordinate system, but let's try to add a value, and let's add just a number 43.21, and it will give us an error. It shows that tuple object has no attribute append because tuple just cannot be modified. So this is it about tuple. Another data type that we have are sets, and it is really similar to list in many ways. So to show that, let me first create a list of let's say my friends. Okay, so let's create a list of my friends, and it will be, sorry, inside a big bracket of course, and inside my friends I'll make Alex, Sam, and then Leonard. I don't know how this came over here, Leonard, and then Sheldon. So here is a list, it is a beautiful list, and let me print this list. Okay, so as you can see, this list gets printed. It is a simple thing, right? We have already known this. But if you observe carefully, the order of how we declare the list is always consistent. I mean, I kept Alex at first, and Alex is kept at first here. Then there is Sam, and here is Sam. There is Leonard, and here is Leonard below. So no matter how many times we run it, it will give the same output. the list that we have declared, and we can use this to our advantage. So we can use this to extract a value from our list. So let's say we want to extract Sam. So Sam here is in the second spot, which in programming is index 1 as we start counting from 0. This is a really important fact that we have to remember every time that you are coding. So my friends one, and let's print this, and it will give us Sam here. So this is a very useful property of list. But let's do this again with a set. And a set is different from list in a way that it uses curly brackets. Everything else is same, right? And what if I again try to print my friends, but this time it is not a list but a set? Let me close this terminal and let me close this terminal and open it again. So this time it gave Leonard, Sheldon, Sam, and Alex. But this is not in the order that we declared the set. So this is because a set is unordered, and if we run this code again, it will give us a slightly different order of elements, and this is totally fine. So this is the difference between a set and a list, that a list is ordered and a set is unordered. So what we can't do with a set is we cannot use the property of a list to take a value from an index out. So let's try my friends and index number 0. So if it were a list, it would give us the value of Alex, but as it is a set, it will give us an error. So I want you to remember this difference between set and a list, and then the difference between list and a tuple, a difference between a list and tuple and set, and so on. Now another data type we are going to discuss, and it is a bit different from other data types like sets, list, and dictionary. Set, list, and tuple that we have discussed, but it is made up of those data types. And in other languages and in other practices, we also call it a hash table. So let's say I have to make a data type that contains the contents of my result. So let's say my marks in my result, and we will create a dictionary. A dictionary also use curly brackets just like a set. And here I will give a key, right? So this is the name of the subject, physics, and then I will give the value. So I got 78 in physics. Let's assume we will separate, then we will give a comma to separate the value, and let's create another key, which is chemistry, and it, let's say I got 98 in chemistry. I'm really good at chemistry, let's suppose, even though I am not. I really hate chemistry, I hated it during high school. I got good enough grades, but hating a subject is still hating a subject, and not to bluff much, so I need to keep myself uh, in my limits. So I will fail myself in math, so I give myself 38 marks. So let's see this dictionary properly. All right, so in this dictionary, every single element has two values. So it is like a value that is linked with another value, then a value which is linked with another value, right? In physics I got 78 marks, and this is one element. Then in chemistry I got 98 marks, and this is an element. So it shows the relationship between what we call a key and a value. All right, so it shows a relationship between a key and a value, and the first one is considered the key, the second one is considered the value. And we can use these key value relationships to do various tasks like extracting value from key, extracting multiple information, but we are not going to do that right now. We will do it later on when dealing with problems. Okay, so right now I do not want to go deep into dictionaries. Instead, I want to start something called flows and conditions, and to do that I'm going to start with if else statements. So let me think of a problem. All right, so I need to find out I need to find out right I need to find out whether to go to school or not. So there is generally two cases if I should go to school or not, and that is if the school is in holiday, if the school is closed, I do not need to go, and if the school is open, then I need to go, right? So uh, for that, let me assume that okay, so let me assume that is school closed, and right now I will give it a value false. Okay, and okay, so the school is not closed as I have given. Then if else statement is written as follows. So we will give the first condition if is school closed is equals to true. So a single is equals to denotes that we are giving a value to a we are assigning a value to a variable, whereas a double equals to checks, it is like in conditional operator, it checks the value, it compares the value of is school closed with true, and if is school closed is true, then it will go inside the if statement. So let's say print you you don't need to go to school, and what we can do is we can give an else statement, right? If the school is closed, then you don't need to go to school, else let's print you need to go to school. All right, so let's run this, and it says you need to go to school because the school is not closed. Now, what if the school is closed? It will give us an output. You do not need to go to school. So this is a case in which we can use, you know, if else statement. And let's say there is another argument that we want to give. All right. So I'm also trying to show you about operators right now. Okay. So is school closed and are you sick, because we won't go to school if we are sick too. And uh, are you sick? And yes, I am okay, so I am not sick. All right, so is school closed is equals to true. So this part doesn't, even if this part is false, let's say the school is not closed, then if we are sick, let's say if we are sick, then we can't go to school. But if I run this, it will say that you need to go to school. So we need to change the code. We need to change the code such that when the school is closed and when the school is not closed and I am not sick, then only I will need to go to school. Otherwise, I cannot go to school. So, two conditions must be fulfilled here. That's why we will alter the code here. Is school closed is equals to true. You don't need to go to school, and we can add or, you know, if this condition is true, or if are you sick is equals to true, then also I don't need to go to school. So let's try this. And yeah, it says that you don't need to go to school because I am sick here, even if the school is open. And another way to write this, are you sick is equals to true, can also be are you sick is not equals to false. You know, I'm trying to show the symbol for equals to and not equals to. So, and there is another way of writing this, and which is simply to write or are you sick. So are you sick will return either true or false, and if it is true, then it will go inside the if statement. And here it says that you don't need to go to school. I hope that I have not complicated things. I really hope so. But even if you feel a bit lost, you can rewatch this clip again, or you can just proceed forward, and you will explain. You will understand as we go. Now, the next thing that I want to talk about is loops, and the loops that we use in Python are for loops and while loops. So let's talk about for loops first. All right. So let's say that let's say that my girlfriend is upset with me. Okay. So, yeah, so my girlfriend is upset with me, and she says that you need to write my name 100 times, you know. No, no, no. You need to write my name 1,000 times in a Word file. Then only I will stop being angry at you. Then what will you do? Will you start typing your name? Let's say her name is what's a girl's name? Let's say her name is what is a girl's name? I forgot a girl's name. What can be a girl's name? Let's say her name is Samantha. All right. So will I go on to write Samantha for 1,000 times? No, I am a programmer, so I will use programming logic. All right. So what I will do is write a for loop. So for I in range, I is just a variable that you can make whatever. So for let's I can write it at index, I can write it at nothing. All right. I really hope that nothing is not a built-in name in Python. And for nothing in range, let me and we need to write it 1,000 times. So I will give it a range of 1,000, and I will print let's say I am sorry Samantha, and let's run this, and as you can see it has printed Samantha I'm sorry Samantha 1,000 times. So yeah, I saved you a lot of time, but most of the times we won't be apologizing using for loops. Instead we will be doing something useful. So let's say that I need to print numbers from 100 to ones, but 100 to 1 in opposite order. So to do that, I will just write a for loop for I in range, and I will specify the range. So the starting index will be 100, and the thing in of this range function is that it is exclusive, which means that it will not include the second number that we keep. So if I write 0 here, the I value of I will only go to 1 and it will not go to 0. It's really similar to what we have in statistics. All right. And this one simply means that we will be taking one step at a time. uh, and here let me close this, and I will just print I. So the value of I will move from 100 to 0, right? It will stop right at the value 0, so it will go to value 1, and it will take one step at a time. If I print I, sorry, what is the problem here? Is there any problem? For I in range 100 to 0, oh, sorry. We will not be taking one step at a time. We will be taking negative one step at a time because we are decreasing the value. And as you can see here, we have 100 to 1. So what if I want to decrease the value by 10? I will make the steps 10, and it will give us 100, 90, 80, 70, 60, and so on. So if I have a value negative 1 here, then we will also get the value 0. See, so this is for loop, and it is really useful, and it will keep being useful. So while loop is different than for loop, of course, otherwise it would have been the same thing. So while loop executes a block of code while a statement is true. So it just goes like while true, you know. And while something is true, this block of code will keep being executed. So it, let's say, yay, let's print yay, then it will go on forever and ever until our memory gets full. We do not want that, right? So we will be giving a condition uh, where where the where this becomes false. So let's say while am I rich is equals to false. All right, so right now I am not rich. Okay, am I rich? Because I'm not rich, I'm poor. I'm not rich. That's obvious, right? I am rich is, oh sorry, I made a mistake here. I am rich is false, and right now this block of code will become will keep running. So I will print earn some money, and then I will give some money to myself. So let's say my balance bank balance is equals to 100 rupees is the currency that we use here, so it will be 100 rupees. And every time I say earn some money to myself, and every time this loop runs, I will add a value of give uh, I will give myself 50 rupees. So bank balance becomes bank balance plus 50. And when if bank balance is greater than and equals to, when bank balance becomes greater than and equals to 1,000, then we will say that we are rich because we have more than 1,000 rupees. And that's real that's a level of true you know wealth. 1,000 rupees, what more do you want in life? So let's run this code, and yeah, it will say us earn some money. And what we can also do is we can print the current bank balance here. So your current bank balance is, and then we will write a comma here, and then we will give the value bank balance. So this is a string followed by an integer, and let's run it again. So at first it will say on some money, your current bank balance is 100, then it increases to 150, 200, and when the last time the code is executed is when my bank balance is 950. Then what happens is my bank when my bank balance becomes 1,000, and my rich becomes true, and it doesn't enter the while loop. And another thing that you have to consider is that in Python, indentation is really important. Indentation means these four spaces. If I remove these four spaces, it means that it is outside the while loop, and it will give us an error. So we have an hierarchy system, and anything that is inside the while loop has to be a tab, or let's say four spaces inside the while loop. And then this mi_res is equals to true is inside the if statement, so it is again one indentation uh, ahead of if statement. So I hope you guys have understood while loop. Now let's talk about operators in Python. So in operators, what we have are first mathematical operators like sum, which is carried out by the symbol plus, then subtraction, which is carried out by the symbol minus. So let me give you an example of sum. Let's print 2 plus 2, so it should give us an output 4. And here we have an output 4 for subtraction. Let's print 4 minus 2, and it will again give us the value. Alright, it will give us the value 2. Now moving on to multiplication. We will use the symbol asterisk, and let's try it out once. 4 times 3, it should give us an output 12, and here we have the output 12. So this is about multiplication. And for division, we have two types of division. We have two types of, sorry, for division we have two types of it. So the first one is integer, sorry, real division. So this is the actual division that we usually do in mathematics. So let's say print 3 by 7. All right, sorry, 7 by 3. So this is a real division, and it uses the symbol slash, and it should give us a value 2.3335. But the other kind of division is called integer division, and it will return us an integer value instead of float. We will use two slashes, and let's print 7 by 3, and it will give us 2. So this is the value when 7 is divided by 3, and there will be a remainder when we use such type of division. Now to know what the remainder is, we will use something called modulus function, and modulus function in Python is denoted by the percentage symbol. So to get the remainder when 7 is divided by 3, we will use 7 percentage 3, and it will give us an output of 1. So I think this is about it for mathematical operators. Another thing we need to do is the order of execution, right? Order of execution. So the order of execution is mm, you know PEMDAS, we can say, where this is parenthesis, exponents, multiplication, division, addition, and subtraction. Okay, so if we need to do something like 2 plus 3 first, then sorry, 2 plus 4, then we need to divide it entirely by, let's say, 3. Then what we need to do here is put the 2 plus 4 in brackets. So it's just simple arithmetic. I don't think I need to explain this to you guys. So the output of this will be 2 plus 4 6, 6 by 3, which is 2 and 2.0. Yeah, so this is the output, and I don't think I need to explain it to you guys. And so one thing that I missed was the exponent operator. And to do exponents, let's say 2 to the power 16, 2 to the power 16, we will use two asterisks, and let's print this. I don't know what the exact value of this is, and it is 65,536. So yeah, this is how we do exponents in Python. Now the other type of operators that we have uh, are comparison operators, and that can be, let's say, sorry, to denote is equals to, we will use 2 equals to sign, and to denote is not equals to, we will use not equals to sign. And all of these comparison operators will give us a value either true or false. So let's say, let's print 4 is not equals to 2, and this is a true statement, so it must print true. And when we change it to equals to 2, it will give us a false. So yeah, these comparison operators will give us a Boolean value as an output. And one thing that you need to remember and not be confused is with confused with is that a single equals to denotes assignment. Let's say I say a is equals to 12, then it means that the value 12 is assigned to the variable a. But when we use 2 equals to signs, let's say a is equals to 2, then it is used to compare the value of a with the value 2. So this is the difference between equals to and double equals to. Now let's talk about less than. Less than is of course this sign, and we also have less than and equal to, which is less than and equals to. The same goes for greater than. Greater than, we use the greater than symbol, and for greater than and equals to, then and equals to, we will use greater than and equals to. So these are the basic conditional comparison operators. What we also have are bitwise comparison operators. So bitwise comparison operators like in the basic logic gates, what we have are and or. So and is denoted by either the symbol, either writing and itself, or we can also use this symbol, and for or we can use this symbol. So let's basically go over and or. So uh, and is only true, is only true when both sides of the expression are true. For example, uh, a and b, the value of a and b will only be true if both the expression a and expression b are true. So let's give true and true, then it will output, as you guessed it, it will give us true right here. But if we change the value of even a single one, then it will give us false, right? And what if we give an or here? Or gives us the value true even if a single one of the values is true. So this is about and an or and operators. Now we will move on to functions. And before talking about functions, I would like to give you a problem, which is to write a program that uh, let's say that checks if a number is odd or even. Okay, so I want you guys to do this, write a program for this. If you have written the program, continue with the video. First pause the video, and then after writing the program, continue with the video. It doesn't matter if you cannot solve it, I will do it right now, but please try to attempt to solve this. So let's approach this problem. To know whether a number is odd or even, we can use the fact that every even number can be divided by 2, and odd number, and when we divide an odd number by 2, we will get a remainder 1. So we can use that fact. So let's say if the number, let's say we are giving the number 13, is when divided by 2 and the remainder is 0, then we will print that the number is even. The number is even. Sorry, that the number is even. And if the remainder is not true, then we will, sorry, if the remainder is not 0, then we will print that the number is odd. Fairly simple, right? Let's try to run this, and the number is odd, and 13 is indeed odd. So what if we want to do this again with a different number? We just copy the code and then paste it here and change the value of 13 to something like 67, and it does work, right? We are getting the output for both 13 and 67. But the problem here is that while writing a program, it is the first rule to never repeat any line of code. I mean, what we have already made, we need not to repeat it. And here we are having to repeat the same code for a different number. So what we can do is we can create a function. So let's create a function is odd or even, and in the function we will pass a parameter number. I will explain what it means in a bit. So yeah, we have defined a function, and inside this function we will just write this block of code, change this 13 to number, and any time that we need to know whether a number is odd or even. Sorry, let me fix the indentation here. Print the number is even, the number is odd, else needs to be indented. Okay, so every time that we need to know whether a number is odd or even, we can just call the function. Till now we have only created the function, so it does nothing. Let me show you first. If we run this, it will, why is it giving us invalid syntax? um, Let me close this. Let me just remove this and this, and let me run it again. And yeah, it does not give us any kind of output, or it just nothing happens. It is because we have only defined a function and we haven't used it. So anytime that we need to know whether a number is odd or even, we will just call the function and give the parameter here. So let's say 67, and if we run it, the number is odd. Then when we need to know whether another number is odd or even, we will again call the function and give it a different value. So let's say 28. 28 is even, so it will return us the number is even. Yeah, so one thing I want you guys to know about functions is also the variables inside the function. So what if I were to print a number here? Yeah, we have given the value of 67 to number. So will it print the value 67 or the value 28? And the reality is it will give us an error that number is not defined. This is because number exists only inside the function, and it is what we call a local variable. So it cannot be used anywhere outside the function. If we were to create a variable number here, if we were to create a variable number here, then while printing number, we will obviously get 17. This is because what we declare inside the code, what we declare here is a global variable, and it can be used anywhere inside the code. But what we declare inside a function, it is called a local variable, and it can be used only inside the function. Yeah, so this is about local and global variables. Now let's talk about what functions are actually used for. All right, so let's modify this a bit. Let's make the function name is odd. All right, so functions are generally used not for printing stuff but for returning a value. So uh, the function is odd. Let's say that it returns either true or false. If the number is odd, then we will get the value true. If the number is even, we will get the value false. So here, if the number if the remainder of the number being divided by 2 is 0, then we must return false. All right, and if the number else all right, if the number divided by 2 gives the remainder 1, then we will return true. And what if we just use this function again and give a value of 17? It does not give us any kind of output because it is just returning a value. So we need to store this value inside a, you guessed it, variable. So let's say my var. I'm really bad at naming things. If we run it, nothing happens. But what we can do is we can print my var, and it will give us true. So this is what I have been wanting to make you guys understand, is that functions are generally used for returning values rather than only printing values or performing a certain kind of code. In other programming language, there is distinction called procedures and functions, but in Python, a function can either return a value or it can just return nothing, and we do not need to, explicitly state whether it returns something or not while declaring it. So yeah, this is it about functions. Now that we have completed the first part, which is to learn the fundamentals of Python programming, and before approaching the object-oriented programming concepts, I would like you guys to do these three problems, and I want you guys to pause the video, solve these three, and then come back to the video and check whether what you have done is right and whether I do it in a different way than what you have done. So to approach the first question, here we need to define a function to convert Celsius to Fahrenheit. So let's name this function Celsius to Fahrenheit, and we will give it a parameter which is Celsius value. And in this function, what we need to do is we need to convert it to Fahrenheit. So Fahrenheit value is equals to, let's follow the hint. It says that to convert from Celsius to Fahrenheit, we need to multiply it by 1.8 and then add 32. So let's do that first. So we need to first multiply Celsius value by 1.8, and then we need to add 32. So we have now converted into Fahrenheit. Now we need the function to return Fahrenheit value. Now let's check if the function works. As far as I know, the normal human temperature is 98.6 degree Fahrenheit, which must be 37 degrees Celsius. Let's check if that is the case. So Celsius to Fahrenheit, and we will pass the parameter which is 37 degrees Celsius, and it does not give us anything. I want you guys to know, guess why it is not returning anything. It is not printing anything. This is because this only returns a value, and to get it on the screen we need to use the print command, and let's print it on the screen, and we get 98.6000001. Let's not worry about why we have this one here. It is a kind of mathematical error that happens with calculations in a computer. We will not discuss about it right now, but in some later videos we will absolutely talk about it. So yeah, this is the code for question number 1. I will comment it out. Now let's move on to the second question. We need to write a program to find the greatest number from 3 inputs. So let's take 3 inputs at first. Input, enter number A, the first number, enter the first number, and we will just copy this for 3 times, and the first number, then the second number, and then the third number. And we need to store these inputs in a variable. So A equals input, let's store it in 3 variables, A, B, and C. So we need to find the greatest number from 3 inputs. So what if we use if statement? So if A is greater than B and A is greater than C, right? Why did this execute? Okay, so if A is greater than B and A is greater than C, then let's print that A is the greatest number. Sorry, the first input is the greatest number, or let's change it to A is the greatest number. Okay, so from right now what we have learned is only if and else. but in this case we cannot do only if and else is not enough to find the greatest number from three inputs, because okay, we for this we have done a greater than b and a greater than c. In else we do not know whether b is greater or c is greater. So what we will do is we will use else if b is greater than c and b is greater than a. All right, and we will execute this here, but we get an curly bracket here, right? This is because else if in Python is written as elif, so it will give us the chance to check another condition before moving on to the else statement. So elif b is greater than c and b is greater than a, then we will print that b is the greatest number, is the greatest number. Now finally, if both of these are false, then we will do else and we will print that c is the greatest number. I hope that I have made this clear to you guys. Let's run this code. And it gives us enter the first number. Let's enter 2, 3 and 4, and it gives us 4 is the greatest number, so our code works. So problem number 2 is solved. I will comment this out. To comment anything out, we need to select it all and press Ctrl and question mark sign. The question mark symbol is right above the shift, right beside the shift symbol. All right, so write a program to display this pattern. So this one requires a bit of for looping. Okay, so here, okay, I will change this program a little bit because why not. So let's change this pattern into something like this, where at first we have 1 star, then 3 star, then 5 stars, right? So for this, what we need to do is for I in range. Let's create a for loop, and the range will start from 1 and it will move on to 6. Why I have given 6 is that because the last index in this range function is exclusive and we need to move 2 steps. Okay, so for I in range 1, 6 and 2, we will print times I times the string, and the string here is asterisk. So let's try it out, and yeah, it gives us this output. So here we have it. We have now solved 3 problems, and now we will be moving on to OOP. If you have any confusions, make sure to leave it in the comments down below. Now moving on to object-oriented programming. I need to illustrate it to you guys first. So now talking about object-oriented programming, we need to understand 3 things here: class, method, and object. Classes, methods, and objects. So now let's talk about class. Class is like an outline for what an object is. So it's an outline of code, and it does not get executed. It does not get executed by default. So it does not get executed by default. And to run this code, to run this block of code, we create an instance of it. We create an instance, which is what we call an object. All right, so we create a class, and this has an outline code, and to run it, we create an object of it. We create an object. And the beautiful thing about OOP and the classes and object is that we can create a class A once, right? We created class A once, and we can create multiple object of it. So we can create object B, and we can create object C, and we can create object D. So we can use this class multiple times to make object, and every object can do the same thing but in a different way. So it helps to reduce code redundancy, just like what we did with functions. But classes are much vaster thing than class functions, because methods in a class is just another name for function. So a function inside a class. So we made a class here and we wrote a function here inside the class. Then the function is what we call a method in the class. So for further illustration and further explanation, I will just show you the code. So to create a class in Python, we will just write the keyword class and then specify the name of the class. Here I will create a class named student, and we have created a class. Now inside a class, what we have at first is its constructor, and constructor is the method that gets executed at first when a when an object of a class is created. So when we create an object, the first method that gets executed is the constructor. And in Python we have the constructor, which has its own name, and it is called underscore init init. And inside init we do not need to pass anything, so we will just pass self. And self is a keyword that I will talk about later on, but for now we will just give nothing to the constructor except for self. And let's do one thing. All right, so we will just print that the the object uh, the object is created, and let's save this. uh, okay, let's run this and nothing happens. This is because even though we have defined the class and it defined the constructor method inside the class, we have not created an object of the class. So let's create an object of the class. To do that, let's say first student that we talk about is a student, and we do not need to give any values to it because there is nothing that it asks us for. So now that I have created an object of the class student and the object name is first student, and when I run it, it gives us the output: the object is created. And I can create multiple objects for the sorry, not second, first student, but I can create multiple objects with the same class. So second student is also student, so it lies in the student class. So yeah, and we get two outputs: the object is created. I hope that you have now got a general overview of what a class is. Class is just an outline of code, and the code gets executed when an object is made. And the part of the code that gets executed at first is the constructor. Now let's give some values uh, to the student class. So to give some values, we will first initialize the with the name. All right, we will just initialize the class with name, and what we will do is self dot name is equals to name. All right. So now let me explain what self means. So again, I will create the first student is equals to student, but this time in the constructor I also need to give the parameter name. So I will give a name, and that is Sam. So there's a student named Sam, and the object and while creating the object, the constructor gets called. Inside the constructor, we have given self. Self is a special feature of Python that helps us to use this name inside other methods in the class. So if I were to define another method, so get name, if I were to define another method which is get name, and if I were to uh, you know and if I were to make this function so that it returns us the name of the student, and if I try to get first student dot get name, then it would give us an error. Yeah, so students dot get names takes 0 positional arguments, but one was given. So automatically what happens is when we call a method, it gives the uh, positional argument self, and self, okay, let's give it self. And when I try to return name, it says that name is not defined when we have clearly given name to this object for student, and the name is Sam. So why does it give us the error that name is not defined? This is because the name here is a local variable, and that is accessible only by the constructor. But in order to use it, make a name usable by other methods inside the class or inside the object, what we need to do is we need to use this self. So self is such an argument that is given to all of the methods inside a class. So self is common for all the methods inside the class. Every method can use self. And if we were to save this name inside self, so if we were to save this name as a part of self, then we can use it in the other methods just like this. So self dot name, and if I were to run it again, this will return us the name, but we need to print it on the screen. And as you can see here, we have Sam on the output menu. So self is just a common argument that is given to all of the methods in a class, and it helps us to use variables that are given to a single class, a single method. So if we were to give Sam to constructor and store it inside self, it would be usable by any other method in the class. Now let's define another method inside the class, which is define set address. And so basically, when we create an object, let me remove this part of the code. When we create an object, an instance of the class student, we only need to provide the name. But in reality, we might need to optionally put more values, give addresses, give phone numbers. But while creating the object, we only need to give the name. And what if we want to add other values like address or phone numbers and stuff? Then we can define a method to set those values. So let's define a method set address, and it will take self, and it will also take another argument which is address. Now what we need to do is store this value of address inside self so that it can be used by other methods in the class. So right now the student is created, and it only has its name, right? So let's try to print first student's name. So first student dot name, right? So this self also helps us to extract variables from an object, so we can use it to our advantage. So this first student dot name indicates to self dot name inside the class. So it gave us a value Sam. What if I try to do the same with address? because, and then we get an error. Student object has no attribute address. So this is because while creating the object, we do not need to provide the address. We only need to provide the name. But after creating the object, we can set the address to the object, and to do that we will just use the method dot set address, and we will give the address which is Nepal. Okay, Sam lives in Nepal. And then I run this, nothing happens. Now what if I try to print the first student dot dot address? Now this will give us Nepal. Okay, so everything is going fine right now, and we could have done all this without using class too, but the main reason we use class is that we can make multiple objects. So second student is equals to student, and we name him Sheldon. All right, and then we set the address of the second student, and to do that we will just do second student dot set address, and he lives in, I guess, Texas, right? Sheldon lives in Texas, for those of you who have seen the Big Bang Theory. And another object is created. Now what I can do is print second student dot address, and it will give me the value Texas. So yeah, the object-oriented programming is a really cool concept that we will now mostly be always be using. Now let's talk about another really important topic in OOP, which is inheritance. So inheritance by definition means to inherit something, like let's say your father's money and his property will ultimately become your property, so you inherit that from him. A similar concept is used in OOP. So let's say we have a class which is named fruits. All right, so we create a class fruits, and any property that a fruit has is that it is edible, right? It is edible, it is tasty. Let's say it is edible, tasty, and it is also healthy. So these are the properties of a fruit, and we can assume that every fruit in the market always has this property. So if we were to create a class which is apple, we can find that apple does have these three properties. And if we were to create another class named bananas, it would also have this property. And if we were to create another class named pear, it would also have this property. So what we can do here is we can create this fruit class as a parent class, and make these other classes as the child, and a child will inherit all the properties of the parent. So to do that, let's move on to the code here. Yeah, so in the code I'll clear this out. So let's first create a class which is fruit. Okay, so a class fruit is defined, and in the constructor we will give self, and then we will just print it is tasty. We will print uh, it is edible, and we will also print it is healthy. All right, so we created a class fruit, and to take all the properties of fruit in the class, or the class, let's say apple, what we can do is inherit the properties of fruit. So we will give the properties of a fruit to the apple, and apple becomes a child class of fruit. So let's define init, right? And what we are doing here is these three print statements here are in the constructor of the parent class, and to call the constructor of the parent class we will use a keyword which is super, and it is used to bring out the constructor of the parent class. So what if I create an object of the class apple? So let's say first apple. So first apple is an object for the class apple, and if I create this, it will call the constructor of the fruit class, and it will print those values even though we haven't created an object of the fruit class itself. This is because the class apple inherits the fruit class. And what if I were to assume that every fruit in the market costs the same? All right, so every fruit in the market costs the same, and let's say that self dot cost equals 100 rupees. Okay, and this cost is a variable that is linked to self, and this is linked with fruit. So if I inherit the properties of fruit, and I have assumed that every fruit in the market costs the same, so if I were to print the cost of apple, will it give us the value? So first apple dot cost, even though this is not the cost is not mentioned inside the class apple, will it give us the cost? And it does. It gives us the value 100. It is because we are also inheriting the keyword self of the parent class, and everything that we have given in the parent class is inherited into the child class, and it is a property of the child class itself. Now the last thing that we are going to learn in this beginner Python tutorial series is file handling with Python. So yeah, we can also manipulate files using Python, and to do that we will create a variable file is equals to open, and we will enter the file name here. Let's create the file name as first.txt, and then first.txt, and we have to specify what mode we will be opening the file in. So there are three modes to opening a file. The first one is W, which means write, and it will write from the first line of the file, text file for in this case. Another mode for opening a file is R, and it means read, and as the name suggests, it is used to read the contents of the file. Another mode that we have is A, which means append, and it will start adding content to the file right from the last line. So in this case we do not have a file, so we will need to create it, and we will create the file using write mode. So file dot write, and we will be giving a string to the file, and let's say this file was created using Python. Okay, so let me run this, and it shows nothing here, but if I open the menu and see in the folder Python tutorial, you can see that first.txt has been created, and if I open this, in the first line we can see that this file was created using Python. All right, so we have already created a file. If I again do this, it will just create another file and replace the existing file. I can change the name of the file, and it will create another one, second.txt, and it created second.txt here with the same contents. Now what if I open it using append mode and do the same? Then second.txt has this file was created using Python, starts right where the first line ends, but I want it to have a space, so I want it to start from the second line. So what I can do is I can put slash n here, and this will create a new line. So I will change it in the file first.txt, and it should start from the next line. And as you can see, this file was created using Python. And what I can do here is, if I create a for loop for I in range 5, this will add 5 more lines to the existing file. So let me run this and go to first.txt. So 5 more lines have been added, and there are now 7 lines in the text file. Another mode that we have is read, and it will file dot, and let's remove this part, and let's file dot read, and let's run this. Okay, so we need to store it inside a variable. So read contents, let's name it read contents, and it will be file dot read. Let's remove the loop here and then change the indentation, and let's print read contents. And as you can see, it reads all the content inside the file. Yeah, so these are the basics of file handling. And for more knowledge on Python and to develop your skills, what I would suggest you to do is learn about Python libraries, and frameworks. So the further work that you do from here is to choose what you want to do with Python. By Python, you can do various things like first is web development, especially backend. Web development, you can do backend, and that can be done using frameworks like Django and Flask. Then do you can do data illustration using a Python library, I think, and that is called matplotlib. You can solve mathematical problems using the library NumPy. And then there are other libraries like scikit-learn. Yeah, and yeah, so what I want you guys to do now is research about what you want to actually do using Python, whether you want to get into web development, and whether you want to get into some things like machine learning. If you want to get into machine learning, you can use TensorFlow, right? You can do various things with Python, and if I were to tell everything about that right now, the video would be too long. So now you have understood the basics, and what I want you guys to do is research, find what you like, what you are interested in, and once you find the thing that you like, learn the frameworks, learn the libraries, and keep coding. Thank you.